This lecture relates to the critical thinking component of the lesson on correlation. After completing this lecture, you will be able to understand and apply the 5 main ways to reinterpret a correlation. So let's begin. To review, a correlation measures the degree and direction of the linear relationship between two variables. What this means is that the strength of the relationship between two variables is represented by the value of the correlation. Remember Cohen's guidelines here. Around 0.1 is weak, 0.3 is moderate, 0.5 and above is strong. A correlation also tells us about the direction of the relationship. For example, the variables could be positively related, meaning that as one variable goes up, the other goes up, or as one variable goes down, the other goes down. Or the variables could be negatively related, such that as one variable goes up, the other goes down, or as one variable goes down, the other goes up. Here, positive means moving in the same direction, and negative means moving in opposite directions. Now, the age-old adage in statistics is that correlation does not imply causation. So this means that even if two variables are highly correlated, this does not mean that one causes the other. This has become a mantra in statistics, and what we'll do in this lecture is identify other ways to reinterpret that relationship. There are 5 potential ways to reinterpret the relationship between two variables, and I'll discuss each of these shown on the slide in turn. The first way to reinterpret a correlation relates to directionality. This means that a strong correlation between X and Y could mean that X causes Y, or it could also mean that Y causes X. For example, there is a strong positive correlation between the size of the police force and the crime rate, which could lead one to believe that expanding the police force increases crime rate. However, this strong positive correlation doesn't necessarily mean that employing more police officers produces more crime. This is a great example in which we could challenge the interpretation based on directionality and also argue that the increased crime rate contributed to the need for more police officers. As shown in this example, it is not possible, based on the correlation alone, to tell which comes first. You would need a controlled or longitudinal study to demonstrate this. A similar example relates to happy workers being productive workers. Researchers have shown that a strong positive correlation exists between satisfaction with one's job and job productivity. However, it is not necessarily true that liking one's job makes one more productive. It could also be the opposite, that being more productive at work actually makes you more happy. A second way to reinterpret a correlation relates to the presence of a common causal variable. This means that X and Y are correlated because they have a common cause. For example, there is a strong positive correlation between the amount of ice cream sold and the number of deaths that occur from drownings. Don't worry, there's no need to start clearing out your refrigerator. Let's take a closer look at this example. Here, the amount of ice cream sold is our X variable, and the number of deaths that occur from drownings is our Y variable. When the weather is warm, we tend to eat more ice cream to cool down. We also tend to go swimming more when it's warm, which increases the likelihood of more people drowning. Therefore, warm weather is a shared common causal variable here that could inflate the correlation between our x and y variables. In this example, the relationship that exists between the x and y variable is what we refer to as spurious, or existing under false pretenses. Another example of a spurious relationship can be seen in the following. Homicides are more prevalent in areas with a lot of churches. A common causal variable that can be used to explain the strong correlation between the number of homicides and the number of churches is population density. Areas that are heavily populated tend to have more crime. These areas, to meet the demands of the population, also have more institutions, such as churches. A third example of a common causal variable can be seen with this example. Shoe size is associated with better reading performance for elementary school children. In this example, the common causal variable is age. The older the elementary school children get, the more they grow and the bigger their shoe size gets. Similarly, the older the school children get, the more practice they have with reading, so their reading performance increases. So there's no need to try to stretch school children's feet to increase their reading performance. There is only a spurious relationship between the two variables. A third way to reinterpret a correlation relates to the presence of an extraneous variable. This means that x and y are correlated because of a third variable, z, that causes y, but not x. The correlation between the two is therefore completely coincidental. This Business Week article does a good job of illustrating extraneous variables by describing 6 coincidental correlations. Coincidental correlations exist between the number of active Facebook users and the Greek debt crisis, the average global temperature and the NSF budget, the number of babies named Ava and the housing price index, M. Night Shyamalan's movie score, and total newspaper ad sales, Michelle Batman's polling average, and ratings for the show Staten Island Cakes. And finally, this mountain range and the murder rate in New York. As suggested by the captions in each of these examples, it is tempting to make an assumption that the correlations between the variables suggest a causal effect. However, the relationships between the two variables are entirely coincidental, and the y variables, or outcomes, can be predicted by other, more plausible extraneous variables. A fourth way to reinterpret a correlation relates to the presence of a mediating variable. This means that the effect of x on y can be explained by z. For example, a small community had found that when they passed legislation to privatize the sale of alcohol, more alcohol-related deaths started to occur. However, it was not the privatization of alcohol that was the problem. The problem was that the private stores were less likely to check IDs, which increased the rate of underage drinking, which was what led to more alcohol deaths. Drilling down to figure out what could be mediating the relationship between two variables can be very valuable, as it helps you focus more on the cause of the effect as opposed to a symptom. Another example of a mediating variable can be seen in the following statistic. tea drinkers have a lower risk of lung cancer. In this statistic, it's not that tea has the ability to reduce carcinogens directly related to lung cancer. After drilling down to find out why the effect is occurring, you would see that tea drinkers are less likely to smoke, which leads to a lower risk of lung cancer. The fifth and final way we'll discuss on how to reinterpret a correlation relates to the presence of a moderating variable. This means that the effect of X on Y is dependent on Z. For example, an article on CNET presented findings from a study that showed that texting can help you quit smoking. However, the act of texting isn't what makes you quit. It's what you're texting about or who you're texting to. Individuals in the study were texting to a support group who helped give them the encouragement to quit. Here, the relationship between the number of texts sent and the likelihood of quitting smoking was contingent on what the text messages were about or who the individuals were texting to. In this situation, we would say that the content of the text messages moderated or adjusted the strength or direction of the relationship between the two key variables. So now you know 5 different ways to reinterpret or challenge a correlation. And always keep in mind that correlation does not imply causation, even as it relates to this lecture.